In this video tutorial, we're going to show a workflow between Revit, Adapt Modeler, and Adapt PTRC in being able to import a Revit model into the Builder environment, generate a design strip, send that design strip to Adapt PTRC, design the post-tensioning, and then get the post-tensioning back into Revit. We'll show this for one design strip. It would apply to a two-way slab in both directions. We're going to go ahead and start out here in Revit, and we're going to take this model, just this multi-story model. We're going to utilize the Adapt Revit link, and I'm going to go ahead and just export this using kind of the default settings here. We're going to create an IMP file, and that IMP file will be used then to build this model inside of Adapt Builder. The version of Builder we're using here is Adapt Builder version 2019 Build 2. And we're going to go ahead and select this down arrow so that we can select the options that we want. I'm going to turn off Floor Pro, and you can see without any of these programs being enabled, the default that Builder goes to is Adapt Modeler. That allows us to import a model, build a model. We can't really analyze or mesh anything. We can really just construct the model and manage it. I also want to have the PTRC strip mode turned on under modules. That's going to allow me to send strips to Adapt PTRC. So we'll go ahead and select OK. Inside of the Adapt Builder workspace, we're going to use File. I'm going to import the IMP file that I had created previously. So let's go ahead and navigate to that file. And we're just going to import the entire model. We can import loads and combinations. That doesn't really apply in this case because we're just really using the model geometrically in terms of the components imported from Revit. Okay, this is defaulted to what we call multi-level mode, and if we go ahead and rotate this to a 3D view, we can go ahead and navigate, review the model. We could also go into the rendering of the model to navigate and show the model. And what we want to do is really just take a typical level and show an example of generating the design strip for that level and then sending it to Adapt PTRC. So we'll go and select a single level mode, and I'm going to navigate to level 10 here. We're going to use this as our example level. And typically what would happen is we would generate what we call X and Y support lines along kind of these frame lines. So this frame line might hit those two walls. This might go along this wall and then here. This one might actually hook up here, and then we might have something like this, maybe a frame line like that. We would do that in both directions. So in the other direction, we would have frame lines along these columns, maybe here. This column, that might actually be connected to here. We're thinking of this in terms of developing equivalent frames in a 2D modeling environment. That's how we want to generate these support lines. And these support lines have to snap on column centers. They have to snap on beam endpoints if there are beams, wall endpoints. That's important when you're setting up the model to send it to Adapt PTRC, because that program has to interpret those components, and that presents the capability of the program doing that when we snap on certain component endpoints. So conceptually, we've kind of showed what we're doing here. We're going to actually just go and in reality, we're going to create one support line here. We're going to show an example on one frame line here in the X direction. So we're going to go to PTRC Export. I'll be using the strip modeling tools. I'm going to create a strip in the X direction. This really could be direction 1, direction 2, direction A, B. It doesn't necessarily have to be aligned with these global coordinates. So let's go to snap to endpoint. I'll start this at the slab edge, and I'll use snap here. This is actually snap to nearest. Now I'm using snap to endpoint, and we're going to just select all of our columns like so, and then I'll terminate this at the slab edge. And if needed, we could come back and select this and just readjust so it's perpendicular. Because I'm only creating one strip, I'm going to use what's called a splitter. So here under strip modeling, we'll take this and create a boundary. This just bounds off the top edge of this tributary for this strip, and that's done. If we have additional support lines in the X direction, we technically do not need this boundary because the program automatically will determine, let's say, the tributary based on the presence of the adjacent support lines. The next step will be to generate the design strips. Now, if there are any warnings or errors, the program will dump a log that will show you those errors and warnings. Here, there are no issues with this strip. It's created properly. And one thing that you can do is we can go in here under this modeling option. We can just see kind of what the idealized strip looks like. You could actually use tools here to edit. So if I wanted to edit geometry of any of the different segments, I could use this tool to do that. I could use the other tools to edit supports above or below, beam cross sections if there are beams, drop caps, panels, and loads. Okay, and you could actually send this directly to Adapt PT through this button as well. I'll close that module. And it's important to note also that the user should make sure and pay attention to the design criteria that is set up here. We have to preload this with defaults. So you need to go in here and ensure that all of these different options are set appropriately for reflection inside of Adapt PTRC. For example, under the loading treatment, you can see that we're reducing live load. So if the live load on this floor is set to 50 and you're expecting 50 PSF in Adapt PT, but this is set to reduce, you're going to actually have less live load in PTRC. And if you're comparing results maybe with a builder model, those results may be off due to some mismatch of settings between builder and its native group of settings just for finite element analysis, and then PTRC for equivalent frame analysis. Okay. Now, one thing that I do not have on this model actually is loading. So let me actually add some loads here. I'll add 20 PSF dead load, and I'll redo that for live load. We'll say there's 50 PSF live load. Because I've done that, I'm going to actually generate my, I have yet to actually export the data, so that's fine. I can also export the data using this option, execute in Adapt PTRC. This is the option we're going to use here. I'll select the support line. I'll execute. This will launch the opening window for Adapt PTRC. I can select which mode I want to work in. We're going to work in PT mode. And that will open and launch Adapt PT. This is a separate standalone program. I can go into the input of Adapt PT. You'll notice that if you unlock the model, you could use this unidirectional. So I could just send things to PT and then stay in PT. If I want to send something back to Builder, and in this case we're round tripping, we're going to send back to Builder and then back to Revit. But if I want to send back to Builder in specifically Modeler, then we cannot unlock this model. So we're going to assume that everything here is as we want it. We'll go ahead and just run. I can go through the wizard and kind of see what inputs I have. You can see most of this stuff is grayed out. But once you've done that, I can go ahead and run this. So I'll run this in Adapt PTRC. Okay, that will end up at the recycler. This is kind of where the post-tensioning is being designed and based on all the input. This is the profile of the PT. We can do certain things within recycler. Those are actually covered in other tutorial videos. If you look at the Adapt PTRC playlist, you'll find examples for this particular program. But ultimately, we want to make sure that this design satisfies the requirements for a PT design, which might be meeting allowable stresses, precompression, balance loading, deflections, and so on. So once we have set our PT design, and here you can change the force, you can change the profile, there are different ways to modify this. We're going to go ahead and exit. Upon exit, you're going to see this warning that just talks about the tendon being imported back into Adapt PT. So I'll go ahead and close that, and I can set this to the side. Now again, that PTRC model can be utilized as a standalone way of handling that particular strip. back inside of Builder, we want to import that tendon back to this environment. So I'm going to select a strip, and I'm going to use this option to import the tendons back in. And if I just go back to my default screen here, this is the tendon that was designed inside of Adapt PTRC. And if we navigate, we can see the drape. There's additional features that are going to be coming into this particular version of the program that are going to allow some more flexibility in handling tendons. But looking at the display manager, I can turn on control points. I might want to show number of strands, total effective force, just to verify that information here on screen. So there's 294 kips, 11 strands, and you can see the control points along the path of the cable. The next step is going to be and actually export this tendon out and import it back into Revit. So ultimately we would want to do that for the entire slab. We would have, tendons built out for the entire slab. And what we can do here is first go to tendon settings. I want to select this option to export tendon segments in IMP. And then I'm just going to export this. I'll just use this option for latest IMP version. I'll name that IMP file. And then we're going to go back into Revit. If we go to Analyze, we can see that there's actually a couple of different options here. One would be to import the entire model back into Revit. That would update the geometrical components as well as give the user the option to include the post-tensioning. So this looks similar to actually exporting a model out. There's a dialog, there's an interface here where we can go in and select what components we want to include. Here we would select post-tensioning. I would then import the data, and the program would physically represent the PT as chained number 4 reinforcement with the curvature. So that's how the tendons are physically modeled inside of Revit as objects. We're going to go ahead and X out of that, and we're going to show another method here. If we go to level 10, this is the level that we had produced the tendon for. We're actually going to use the option to create some sheet data. So this is more 2D plan type data that we can import from the builder model. We'll go ahead and select this. I'm going to select the IMP file. And we're going to map under tendon, we're going to map level 10 in Adapt to level 10 inside of Revit. So level 10 to 10. I'm going to create tendons. I can create some information related to the tendons. If we had designed the slab for that level 10 inside of Builder rather than sending it to PT, we're just importing the tendons back. We're not importing the reinforcement back. Had we used Adapt Floor Pro to design the reinforcement and the PT, then we could actually import the reinforcement back as well. We're going to deselect these. We don't have any rebar to import back, just the tendons, and we'll just say to update the sheet. And this will basically create that tendon. So you can see this is the tendon that's been generated with some tags and information that can be edited here inside of Revit. This shows the CGs, the profiles, the live and dead anchors, and the force. And this would be comprehensive if you had generated all the post-tensioning cables from PT, imported them back to Adapt Builder or Adapt Modeler, and then went through the same process. If you have any questions about this process, please contact us at adaptsupport@risa.com.